Now we test the bubble measurement function. I used the BGA test. I saved it before. This one, bubble measurement function icon. You can use this icon, or you can use the static mode. It will also pop up. And now we can create a detection box. A single click once, create a detect area, and a single click again, and you will see the difference. The arrows were showing to you. And for the first parameter is the threshold, which is to check the age of the ball. And you can use your mouse to check the grayscales here. In the bottom side, you can see the value here. The maximum is 255. The range is 0 to 255. You can use your mouse to move in at the age of the ball, and you just see one maximum value of it, of the age. For this one is like 180, around 180. And then we need to set the value over 30%, like 210, for example. And you will see they will recognize the age more accuracy than before. You see, if I change it to 100, you see, it will reduce the area, right? So if I set it back to 210, you see the age is recognized better. And for the pixels is the density of the ball, one pad. You see, one contour of one, which is one pad, is one ball, and the pixels is the density of one pad. So if you change to lower, there will be the void will be much more. If you change it to like higher, it depends on the what do you see at the image. But the default is 40, so I suggest you at the first time using the 40 pixels to do the test. For now, the 40 is okay, so we can keep it. And the contrast is for recognizing the BJ void. So it depends on the balls and the void contrast, which is the dark place and the white place. If the dark and white place, the contrast is deep, so this contrast value needs rising a little bit higher. So you can see if I fine tune this value, you see it's near with my eye check, right? So it's accuracy. And the run is, which means the 100% of the run is, if you set it to 100, no void will pass because there's no void like a 100% circle. So I suggest you set this value to 1%. It's okay. And the minimum area and the maximum area, and most of the time we use the minimum area because we need to reduce the very little void area, because there's no effect for the result. So if, for example, I fine tune this one, raise it a little bit, you will see the very little one will be removed. I see the difference. Now the small one will be removed. You see, if I change to 1, small will be back. If I change it to 40, you see, remove. We can keep only the larger one that we need. And the control value, which is the age value, recognize a filter. So if you see, if the through hole, this one is the through hole on the PCB board, which is not the ball we want to check. The size is smaller than the BJ ball, so we can raise in the minimum value to filter this area. We can change it to 40. If it's not gone, we can fine tune the position until the throw hole pad will remove. For now, it's okay. You see, we're only keeping the BJ ball pass. And if you find some situation like the throw hole or another interference error is larger than the BJ ball, so you can use the maximum area. And for now, the all parameters is okay for this sample. We can click the save to save the preset for the bubble measurement function, and you can use the parameter at the next time and not delete. Okay. So for the bubble error check, which is means that we need to as much as near the parameters that we with our eye check. You see, we need to change the parameters that is very close to our eye check, because this parameters is also a reference value for you. And if some of the void is not good, it's not passed, and it's not recognized by the parameters, you can use the polygon or rectangle or fray to draw a new bubble here inside the ball, and you can manually add a new void or new edge inside. You see, I use a polygon here, and then add as a bubble. You see, now I add a new bubble here. And for now, I can use these functions to export a PDF report or XLS report. I'll do both of them, okay? I choose a place and set a name, then save. And the XLS also choose a place, set a name, and save. And you see the two reports. And the first one is the PDF report. It's the same with the measurement report. And the XLS report. You see, like that, with the pictures and with the results. Because this is only one place we check, so the pictures is the same. And it's all okay, you see? Because our standard is 25%, so it's all passed. And this is the user. And here's standard to set, like 25% or 26%. It depends on your choice. And the minimum and maximum size, which is the maximum void area, which is over 10%, is also NG. You can check this option or not. And the bottom one is the total result of the multiple pads, which means we can add all of the pad results and export a total percent here. And in the bottom one is the CNC algorithm parameters. We'll talk this one later, because they were used in other functions. But for now, we will talk the CNC function, which is this bottom, yes. And we used also the yellow folder to create a new program. And here to type a program name, like CNC1. Okay. We can choose to save the original pictures or result pictures. And here's the report, but the report is only for the bubble measurement check CNC mode, which is automatically judgment mode. So if you choose the no judgment and the artificial mode, which is judged by yourself, please disable the report. Otherwise, you can use the report because there were no results. Okay, and you can choose the parameters here. We will see before on the bubble measurement functions. But for now, the first is to use the artificial mode to show you, and we will disable the report. And the enable time means and also we need to save the pass. Choose the save the pass. And the enable means the software will wait you how many times. For example, if you set to 5, each of the ball detection point will wait you about 5 seconds, and after that it will pass the detection point and judge this point as okay. So I'm not suggest you use this mode. I suggest you use the space for a OK and N for NG to judge yourself. Okay. And for now, we can use the next step. And the first method is the enable point, which means that each of the detection point are captured by yourself. Okay. I will do for now, for show. And for now, we need to open the cross grade and also the image drag and drop functions to move to fine tune the position, and use this one to align. Okay, let me zoom out a little bit and try to find the center and capture the first point. You see they have the axis position and also the minimum and the maximum grid scale and the gamma and the power also integrated in one detection point. And we go into another point. And for now, we can change the parameters and also zoom in and zoom out, and also the histogram if you want. And then if you find this one is suitable, and then you can use the image processing for this and capture. And go into another because it's just a quick example, so I just capture 3 points for this program and change the power and capture. And for now it's okay, so I'll complete. And this program is okay, and we will close the cross grade and change the navigation image to SPC image here. And for now we need to run the CNC. And for now you can use this space and the N to judge. It's OK or NG. NG is red, and OK. OK, it's good. And it will show running complete and the item is ready. And you can check the pictures. Okay, because I forget to set the pass, so I'll do it again. Okay, for now it's done. I select the pass, and you can see the pictures like that. And also the SPC image. And in the next folder, you can see the original pictures with no mark. And the next. In the next, we will use the LED board for matrix method capture. Okay, I'll remove this one and use the LED board. You see, I put some mark on it because the background is white. You cannot see. It's not very hard to see which point it is. You can put some mark on the sample like that. And now I do the navigation. After it's done, we can create a new program for it. Click the folder icon, like, and uh, disable the report and check the artificial mode, and select the path and enter the name LED test, and use the enable matrix. And we need to move to the place that we need to check and open the cross grade to align. I also suggest you to use one of the line near the center of the cross grade. It's very useful for you to do alignment for every single detection point. See, something like that. You move it to the center, and then you can near one side of it to let it match, and we can capture the start. Capture the start. Okay, capture the start. And move to the end. This is the big start and the end. Find the end and align again and put the symbol in the same place to make sure it match. Okay, in the end. And I know it because I know it's 3 and 3, so I set it to 3 columns and 3 rows for 9 points. And you can choose the vertical priority for different running paths. It depends on your choice. You can create an array. And for now, it's okay. You have 3 rows, 3 columns, line detection point, and we can cross grade and complete the program. And for now, we can change it to this SPC image and run. And use the keyboard to do the judge and move to the first place. And for now, we need to do the judge. Like OK, NG, NG, OK. It's just an example, so just show you that we have 2 options that you can set. The SPC image, which is to let you clearly see that, oh, I have 5 OK and 4 NG. So, and you see the pictures with results. OK NG, OK NG, OK NG, and the SPC image. And next folder is the original picture. Okay. And for now, we used the third one is the bubble measurement function, the CNC mode. We need to change the board again to the last board we used before, and we put to the platform and let it keep it straight. and do the navigation. Or call. Okay, I'll move to the BGA test and use the cross grade. For example, one row is one plate, one sample. And use this one, static, to create a bubble detection area. Like that. And you need to remember the size of it. Remember the size of it. And use the CNC algorithm parameters. Like BJ CNC. And go into the CNC mode for bubble, which is also void CNC. And we need to use the report now and change it to the automatic mode and use this one, BGA CNC. Open it and use the cross grade to align. And for this, you can use the matrix or also use the point. It depends on your choice. And double click to the center and fine tune the position. A little bit to the center. Capture. Complete. And open the SPC image. Close the cross grade and run. And you'll see they'll automatically show the results. For now it's all okay because it's 25%. And we also can check the pictures and also the report here. Because the parameters is fixed, so it's not very suitable for different interference images. Like you have multiple components on one board, but with no was not the same grayscale images. So, which in this case, that means the parameters are not suitable for the all components. So I think the CNC is just a reference value for you, and also the report. But it's quick. It's quick for manually check, and also the original pictures for manually check. And now we talk about the detector calibration.